What's up, guys? In this video, what I want to do is tackle 3 difficult problems when simplifying complex fractions. What makes these problems a little bit more difficult than other problems really comes down into simplifying our denominators, i.e. factoring. But the general idea and approach we want to do with simplifying complex fractions is going to be the same no matter how simple or complex, no pun intended, our complex fraction looks. So let's go and work through these 3 different examples. So therefore, if you do encounter a problem difficult like this, you're not going to make any mistakes and you can go ahead and get that A. All right, so in this first example, what I want you to recognize here is we have 3 different denominators, right? I have an x cubed, an x squared, and then here I have an x cubed plus an x squared. Now, in this case, I recognize that I can factor that out, right? I can factor out a x squared, and that's going to be times an x plus 1. Now I need to identify what is my LCD. Now remember, your LCD is the least common denominator, the smallest term that all of your terms evenly divide into. So that means x cubed needs to divide into it, an x squared needs to divide into it, another x squared needs to divide into it, as well as an x plus 1. So let's just kind of work from top to bottom. So my LCD in this case is going to be, we have to have an x cubed, right? Now, does x squared evenly divide an x cubed? Yes, it does, right? And again, like if you're kind of confused with that, just go ahead and put it over to the side. How many times does x squared go into x cubed? It goes into there x times. All right. So now we have these 2 covered. We have this x squared is already covered. And then now we need to have an x plus 1, right? Because x squared or x cubed do not evenly divide into an x plus 1. So therefore, I need to include that. Okay. So now we have our LCD, an x cubed times x plus 1. Now what we need to do is we need to eliminate all of our fractions, because I think you'd agree we have way too many fractions here, right? 1, 2, 3, 4. I'm actually going to put a line through there because we factored out our denominator. So what I like to do is multiply everything times my LCD. When I'm multiplying everything times my LCD, that means everything in the numerator as well as everything in the denominator, at least as far as the expressions go. So I'm going to multiply everything here by x cubed times an x plus 1. Now you can apply a little division property here, kind of show it like this, or you can also do something in your head. Just kind of depends on your familiarity with simplifying the complex fractions. However, one thing I have definitely noticed is students make mistakes a lot of times when they're doing things in their head. So what I'm going to do is actually just write everything out so we can easily check on our work as well as see how things are going to divide out. Okay, so now you can see that I took my LCD, right, x cubed times x plus 1, and I multiplied it times my expression in my numerator as well as my 2 expressions in the denominator. Again, this is not going to change the value of the fraction. This is producing what we call an equivalent fraction. Now, remember, when you are multiplying by the LCD, you can also think about it as the LCD over 1. The reason why that's important is because this is represented in the numerator. We want our denominator to evenly divide into our numerator, which in this case, you can see that is happening. Then what we're left over with in the numerator is a 3 minus 2x times an x plus 1. So let's go ahead and write that down below. So 3 minus 2x times an x plus 1. All right, in the denominator here, again, we have an x squared divides an x cubed. Remember, we already did that work, right? X squared divides an x cubed, x times. So that's going to leave us here with just a x and then times 2 times x plus 1. So that'd be a 2x plus 1. And then that's going to be minus here. Now, in this case, you can see the x squared divides into x cubed, right? X times. And then the x plus 1s also divide out. So that's just going to be minus an x. Now, what we need to do to simplify this is just to go ahead and simplify our numerator and combine our like terms in our denominator. So again, just to go ahead and apply FOIL, we're going to multiply everything times everything. And I'll just kind of do this step by step just to make sure we're not going to make any mistakes. So 3 times x is a 3x plus 3 minus a 2x squared minus a 2x. And then all over my denominator here is going to be a x plus 1. All right, let's go ahead and combine my like terms here. So therefore, I'm left with a 2, a negative 2, x squared plus x plus 3, and that's divided by a x plus 1. Now what I like to do here is, again, I want to see if I can factor this, because sometimes when we're simplifying complex fractions, we want to keep on simplifying. And again, guys, this is what you need for the A. You want to see, is there anything further that I can factor this down? So if I factor out a negative here, I'm going to be left with a 2x squared minus x minus 3 all over a x plus 1. Now, this is really important because now I want to see, can I further factor down this quadratic, right? How can I factor a 2x squared minus x minus 3? Now, again, remember, that can be broken down into a product of 2 binomials, right? 2x times an x, right? And we need to multiply to give us 3, but that's going to add to give us a negative 1. So what I recognize here, if I put this as a positive 1 and this as a minus 3, when I go ahead and multiply that out, that's going to actually be my product, right? Because again, check it. 2x times x is 2x squared. Negative 3 times 1 is a negative 3. And then if you multiply my inner and my outer terms, that's going to add to a negative x. So that's going to be all over a x plus 1. And now what I want you to recognize is, because I factored it, these are separated by multiplication. These are now going to divide out. That's now going to leave us with a 2 times an x minus 3, which can be simplified to a final answer of a negative 2x plus 3. All right, now in this next example, you can see we have a ton of denominators. So the main thing, whenever we're dealing with rational expressions, I think one of the themes of a chapter like this is to factor. And that's one of the more difficult reasons why students struggle with rational fractions. It doesn't matter if we're graphing, we're simplifying, we're solving, or we're just simplifying complex fractions. Simplify by factoring is usually what's going to separate our A students from the others. So the first thing I recognize here is I have all these quadratics in my denominator. And we recognize, right, we want to get rid of the denominator, right? We have 1, 2, 3, 4, 5 fractions. So what we're going to want to first do is let's go and factor each one of these denominators to identify my LCD. So in this example, I recognize this to be a perfect square trinomial. That's going to be an x minus 1 times an x minus 1. All right, you could also write that as x minus 1 quantity squared, but I'm going to leave it in factored form so we can go ahead and take stock and see exactly what our LCD is. What two numbers multiply to give me 2, add to give me -3? That's going to be x minus 2 times an x minus 1. So x minus 2 times an x minus 1. Over here, what two numbers multiply to give me 4, add to give me -4? Again, that's a perfect square trinomial, x minus 2 times x minus 2. So that'd be x minus 2 times an x minus 2. And then here's a difference of two squares. So therefore, that's going to be a x minus 2 times a x plus 2. So now I'm just going to go ahead and cross all these out, right? I just want to focus on the factored form. Okay, so the LCD is going to be the smallest expression that has terms that all of these denominators evenly divide into. Or another way you could say that is they all share. So let's just go and list out our expressions that each of our denominators have to include. So we have an x minus 1. I'm sorry. And again, we already have 2 of them, but again, that doesn't matter. So therefore, I do actually need to include this twice because if I only did it once, then this x minus 1 would divide out. I need both of these to divide out. So that's going to be an x minus 1 squared. In this case, now we already have an x minus 1 that will divide out, but I do need an x minus 2. And then over here, you recognize there's 2 of them, right? So if I did the x minus 2, if I multiply by x minus 2 once, that would divide out, but I need this one to divide out as well. So that's going to be an x minus 2 quantity squared. And then over here, also, I need to have a x plus 2 because the x minus 2 will divide out, but I need that x plus 2. Now we're going to multiply this LCD times each and every one of these expressions to see what's going to divide out. Now, when I go ahead and do that, there's going to be a lot of dividing out, and there's going to be some big expressions. So to avoid making this video last forever on me writing each and every term, what I'm going to do is just kind of represent that I'm going to multiply this times that, times that, times that, and then times that. And we're just going to do this one at a time, and I will kind of simplify as we go, looking at what's going to divide out. And again, as long as we did the LCD correctly, my denominators are going to divide evenly into this LCD. Right? So let's go and take a look at this first upper left expression. So the x minus 1 squared will divide out. That's going to leave me with a x minus 2 quantity squared times an x plus 2 times an x plus 3. All right, and then plus over here, when I multiply this, the x minus 2 times the x minus 1 will divide out. So I'll do that. I'm going to have my original x, right? And then I will have only one x minus 1, only one x minus 2, and an x plus 2. So x minus 2 and an x plus 2. So that'd be an x times an x minus 1 times an x minus 2 times an x plus 2. All right, so now let's go and look at my denominator here. So in my denominator, I'm just going to have an x, and then my x minus 2 and x minus 2, those are both going to go ahead and divide out. So therefore, that will leave me with a x minus 1 quantity squared. My x minus 2's, right? Those are dividing out. And then I'm just going to have an x plus 2. And then over in this example, my x minus 2 and my x plus 2 are going to be left out. I'm going to have a minus a 2, right? So my x minus 2 and an x plus 2 will divide out. So that will leave me again with a x minus 1 quantity squared, and then just only times 1 x minus 2. Now, there's definitely a couple different ways we could go about this is multiplying, and there's a lot going on here, right? So let's just go ahead and tackle this one at a time. Whenever we're multiplying binomials, we just want to take this one at a time. Just multiply your certain terms here. And a couple things I also like to do is to use the box method whenever I'm doing anything larger than a binomial times a binomial. But since this is going to be a lot of work, I'm going to do some of this work in my head because I would expect at this point you should be able to multiply an x minus 2 quantity squared, which is going to be an x squared minus 4x plus 4. Okay, so I'm going to put that in brackets, and because that's going to be multiplied by the product of x plus 2 times an x plus 3, which is going to be, in this case, a x squared plus 5x plus 6. And again, you could do FOIL, but I'm just kind of doing it in my head to simplify the process. And then over here, what I'm going to have is an x squared minus x, so I'm just going to multiply my first two terms, which is going to give me a x squared minus x, and I'll put that in brackets, again, just to remind me I'm multiplying those. And then times here, an x minus 2 times x plus 2, that's going to be a difference of two squares, which is going to be a x squared minus 4. Now, again, I'm using brackets for, I don't know, whatever reason. You could definitely use parentheses. It's just a grouping symbol that I want to combine these for. Again, over here, it's going to be an x squared minus 2x plus 1, right? When you expand that out. So therefore, it'll be an x squared minus a 2x plus 1. And that's going to be multiplied by a x plus 2. And then over here, what I'm going to do is multiply the 2 times x minus 2. So a 2 x minus 2. I'm not going to distribute this negative until the very, very end. Okay, so I did multiply the 2 times this. Okay, so I'm going to distribute here. And then over here, I'm just going to expand the x minus 1 quantity squared. So that'd be, again, another x squared minus a 2x plus 1. Now, it's really important to notice a lot of students are like, well, why can't you divide out your terms, right? Why can't I divide out the x minus 2 and the x minus 2, or the x plus 2 and the x plus 2? Because addition and subtraction separate these expressions. You cannot divide out across addition and subtraction. Only if we had everything separated by multiplication could we go ahead and do that. All right, so now let's go ahead and multiply some of these things. So to go ahead and multiply these, what I'm going to do is 4 kind of box method problems. So the way I like to do box method is create a box with the same number of columns and rows as my terms. Then what I'm simply going to do is just multiply the length times width to find the area of each of those boxes. Now, again, you could definitely use FOIL, or you could even do the math in your head, but there's a lot that's going on here. So I'm going to try to keep everything organized and get it all set up. So let me go ahead and set up all the multiplication, and then I'll work my way through it with you. Okay, so now I've set up the box, basically the length times width, and we're just going to find the area of each of these boxes. So again, like x squared times x squared is going to be an x to the 4th, right? X squared times 5x is going to be a 5x cubed, and you just basically work that for each of one of these problems. 5x squared plus 6 is going to be a 6x squared. Let's see, this is going to be a negative 4x cubed. That'll be a negative 20x squared. Let's see, this is going to be a negative 24x. Make sure you make the boxes big enough. That's going to be a 4x squared. This will be a 20x, and this is going to be another 24. Okay, so let's go over here. This is going to be an x to the 4th, negative 4x squared, negative x cubed, and a positive 4x. Over here, we have an x cubed, 2x squared, negative 2x squared. This would be a negative 4x. This would be a positive x, and that's a positive 2. This would be 2x cubed. That's a negative 4x squared. That's a 2x, negative 4x squared. Let's see, that's a positive 8x, and that's a negative 4. Okay, so once you have the boxes, basically what's nice about these is as long as you have things in descending order, then you can go ahead and simplify. You're going to have like terms on the diagonal. So here you can see we have some like terms on the diagonal. Here we do not have like terms because we have some missing terms, which is okay. So now what I'm going to do is just going to go ahead and rewrite these. And it's very important for this problem. We need to make sure we put an extra set of brackets because we're subtracting this whole product. So in this upper left-hand corner, I have this example, which again is going to be a x to the 4th plus a x cubed. And then this is going to add up to a negative 10x squared. 20x minus 24x is going to be a negative 4x. And that's going to be plus a 24. Okay, now I'm going to add that to this product, which is right over here, which is a x to the 4th, and that's going to be a negative x cubed minus a 4x squared plus a 4x, and then all the way over here in this denominator, we have this bottom product. Notice how these are going to simplify. So that's going to be an x cubed, and then I have a x, so this is going to be a negative 3x plus 2. Now here, what I'm going to do is when I do my final answer, I'm just going to negate everything. Okay, so it's just very important when I find like my 2x cubed, I'm actually going to negate it because everything's being multiplied by negative. So instead of writing a 2x cubed, that's going to be a negative 2x cubed. Here, those are going to add to a negative 8x squared, but I'm going to negate it. So that's going to be a positive 8x squared. This is going to give me a 10x. So negating it is going to be a negative 10x. And instead of a negative 4, that's going to be a positive 4. It's like me taking this answer, writing it inside the bracket, and then multiplying it by a negative in each every time. I'm just trying to save some work because I want to write my final answer, which is going to be now combining my like terms. So I'll add my x to the 4th, which is going to give me a 2x to the 4th. Then I'll go ahead and add my x cubes, which is going to add to 0. Then let's go ahead and add our squared. So negative 10x squared and a negative 4x squared is going to be negative 14x squared. Let's go and take a look at our x's. And so let's go and add those to 0. And then I have a 24 is my final number, is my only number that I'm going to have. So that's going to be a 24. Now in my denominator over here, let's go and see what we have. So we have some x cubes. So when I add those up, it's going to give me a negative x cubed. I have a positive 8x squared. Let's see, that's going to be a negative 13x. And looks like that's going to be a plus a 6. Okay, it doesn't seem like I can really simplify anything in my numerator. It does I can factor out a 2 in my numerator. So that's going to be an x to the 4th minus 7x squared plus 12. It doesn't look like that's anything factorable. And then over here, it's going to be a negative x cubed plus 8x squared minus a 13x plus 6. And again, you could factor out a negative, but there's really nothing else that you could be able to do there. All right, so in this next example, we're not getting away from factoring, right? Because we're looking for that a, guys. So let's go ahead and tackle this problem. Now, at least the good thing for this problem is we're not going to have as much multiplication like we did in that last example. That was a lot. You can see it was definitely something doable. It just took a lot of time and attention. Now, in this example, we basically remember whenever we have a fraction divided by another fraction, we can just rewrite that as multiplying by the reciprocal. So I can just rewrite this problem as a multiplication problem by multiplying by the reciprocal of my denominator. Okay, but recognize we cannot simplify anything out. It doesn't matter what's the same in the numerator or the denominator. Only our main terms are separated by multiplication, so we need to factor this out. So what I'm actually going to do is take each and every one of these expressions and completely factor them. Then rewrite the whole problem again in factored form so we can see exactly what we can go ahead and factor out. Again, remember, the key idea when simplifying complex fractions is factoring. This is what separates you guys. First example or first numerator we have here is a 4x squared. That I recognize as a difference of 2a squares. That's going to be a 2x minus 1 times a 2x plus 1. Okay. And again, if you're not sure about that, go ahead and multiply it out just to go ahead and check my work. So that is going to be my first numerator up there. Then let's go and take a look at the 3x cubed minus a 6x squared minus 24x. First thing you always want to do is see what terms we can factor out. And it looks like I can factor out a 3 as well as an x. So when I factor out a 3x, it's going to leave with an x squared minus a 2x minus an 8. All right. Now what I want to see is I have a quadratic trinomial, right? Which we know we can break down into a product of two binomials. And now we just want to ask ourselves what two numbers multiply to give us 8 and then are going to add to give us -2. Well, I know 4 and 2 give me 8. And we want to find the difference, right, between those two. And 4 and 2 have a difference of 2, which is good. It needs to be a negative, so therefore I need to have an x minus 4 and then an x plus 2. Okay, so we're good there. So that's going to be our denominator. Okay, so then let's go and do this one, which is a -2x squared plus a 5x plus 12. Okay, now here I can't factor anything out. So now what I need to know is, well, actually, I'm sorry, I can factor out the negative, and you're going to want to factor out the negative because when you factor out the negative, that's going to give me a 2x squared minus a 5x minus 12. That's just going to make factoring a lot easier when you're not dealing with like a negative coefficient. Now, remember, any quadratic trinomial can be rewritten as a product of two binomials. Okay, so we have a 2x here and an x. Why? Because x times 2x gives us a 2x squared. Now, what I want to do is try to look at what two numbers are going to multiply, give me -12, but are going to add to give me -5 when one of them is being multiplied by a 2. This is where things kind of get a little tricky. So you got to do a little mental math here. And what I'm trying to do is, since my last term is negative, I'm trying to look at the difference of the factors with that product. What I'm trying to add together is 2x times what and x times what is going to add up to give me that -5. So immediately once I start looking at this, I think about what are some factors of 12 that I could work with? Well, I could do like a 6 and a 2. So I'm going to look at what are my factors of 12? First thing that comes to my mind is going to be a 3 and a 4. Now, yes, a 6 and a 2 and a 12 and 1 also. But again, I'm not going to want to multiply those numbers by 12, by a 2, because think about it, if you put like a 12 here, that's going to be 24. You're not going to have a difference with -5. So let's go ahead and try a -4 and a +3 and see what works. And again, like you could try anything. You could do a +4 and a -3. The main thing is though, we want that difference to be a -5. And look what happens here, right? Again, you're just doing a guess and check and just kind of seeing if it works. But a lot of times when students are struggling with factoring, like just pick something to get started. Another key tip that I'd recommend you guys look into is look for other factors in your other denominators. Because again, the whole idea of simplifying is having the same expression in the numerator and the denominator. Since it's in the numerator, I'm probably going to have something that's similar in the denominator of the other fraction, because again, we want things to be able to divide out. And again, checking my work here, 2x times x is a 2x squared, right? We have 3 times 4 is a -12. Yes, 3 times x is a 3x. 2x times -4 is a -8x. -8x plus 3x is a -5x. We're good to go. Okay, so now let's go and look at our last example, or our last denominator, which is a 12x squared. So that's going to be my final answer, plus a 12x minus 9. Now in this case, it looks like I can factor out a 3. So when I do that, that's going to give me a 4x squared plus a 4x, and therefore that's going to be a minus a 3. And again, in this case, we're looking for a difference because our last term is negative and we have a coefficient of 4. So again, I need to break this up. Now the problem with this one, when it was 2x, we know we could break it up as 2x times x. But in this example, I don't know, could I break this up as 4x times x as well as a 2x times 2x? So what I'm going to do is I'm just going to set up both of them and we'll see which one kind of makes sense. Okay, so what I'm going to do is I'm going to kind of go through that trick that I told you, right? This is the denominator in the right-hand side. What was my numerator in the left-hand side? Right over here, right? So what I'm doing is I'm looking for either 2x minus 1 or a 2x plus 1 to be in my answer. So I'm going to assume that this is not going to be my answer because I'm going to want one of these to be able to divide out, right? So let's just scratch this for a second and let's focus on this as my denominator. Now again, we want our middle term to be a positive 4x. So therefore I'm going to want a 2 to be able to multiply by a positive 3. So my -1 to multiply by 2. So therefore there'd be a plus 3 and then a -1. And again, that works as well with 2 because look here on the right-hand side. This numerator is 2x plus 3 and this one's 2x plus 3. Now again, there's a lot that's working on. So again, my main goal was just to factor each one of these denominators, right? All I did was I took each of these expressions and I just factored them separately. And you could do this on a separate sheet of paper or anything else. I know everything looks confusing here, so let's go and rewrite this back our original problem in factored form. Now what we want to do is recognize that everything is being separated by multiplication. So now I can just kind of play the game of let's divide out these terms, right? Those are exactly the same in the numerator and denominator. It doesn't matter if it's across this division bar or across that division bar. Everything is separated by multiplication. Just go ahead and start dividing out terms that are exactly the same in the numerator as well as in the denominator. And looks like this one is on the same. And I think I got everything I need. So therefore, up top here, I have a negative times, those negative, right? So that's a 2x plus 1. And then my denominator here, I have a 3 times 3x. So that's going to be a 9x times a x plus 2. Now you could actually distribute this, or you could just leave it in this factored form. But ladies and gentlemen, if you feel comfortable and understand these 3 problems, I think you have a great grasp of simplifying complex fractions and you are ready to get that A. However, if you're just not sure yet, go ahead to the next video I have for you here. And if you're looking for just a couple more examples of simplifying complex fractions, or you want to go and see the notes and resources I give to my own students inside my courses, go ahead and check out the playlist and links I have for you down below. Cheers.